So that point now we consider in multitasking system. Let's see what is multitasking or time sharing system and how it is different from multi-programming system. Multitasking is multi-programming with time sharing where CPU execute multiple jobs by switching among them. It is almost same as the multi-program system. Instead of executing a single job at a time, what it does, it is switches between the jobs. The second line is time sharing or multitasking is logical extension of multi-programming in which CPU switches jobs so frequently that user can interact with job while it is running, creating interactive computing environment. This feature was not present in multi-programming architecture. Here, the user can actually interact with the program even while it is running. Because the switches between the job is very fast in the system. The operating system is able to keep track of where you are in this task and go from one to another without losing information. This point is also not present in multi-programming system. The user usually uses a keyboard to provide input and monitor is used to get the output. Execution of job is done in CPU speed, and as we know CPU speed is much higher than the user typing speed. So when a job needs input from a user, it takes in normal human speed, and in this time gap CPU will switches to another process of another user and start execute. So we can see here during the time of user interaction, there is a time gap, and the time gap switching of the job takes place so quickly and it is so frequent that the user cannot even understand that they are using a time shared system. Response time should be less than 1. This is one of the most important feature of this system, of this architecture. The user gives instructions to the operating system or to a program directly and receives an immediate response. An interactive system is used when a short response time is required. Timeshare required an interactive or hands-on computer system which provides direct communication between the user and the system. In order to elaborate this point, let's take an example. So here we have time-shared system and has 4 users who are sharing this time-sharing system. Now in this time-sharing system, the switching between the jobs of the user takes place so quickly that the user even doesn't realize that they are sharing the system. If this or the system creates an illusion that the entire system just belongs to one person and all the users here thinks the same because the switching between the jobs take place so quickly that they don't have realized that time sharing and or the multitasking is occurring in this system. So in this time shared system, uses CPU scheduling and multi-programming to provide each user with a small portion of a time shared computer. Or we can say share the computer simultaneously. Now some features that you have to remember for multitasking or time sharing or interactive computing system. The first one is each user has at least one separate program for executing in main memory. And the second one is a program loaded into memory and execute is called a process. So remember this point. What is process? A process is actually a program in execution. Whenever a program is loaded into the main memory for execution, for execute by the CPU, then we can call that program process. So about process we will discuss in another chapter. The next is job scheduling. This is also one of the important feature which is also introduced in multitasking or time sharing system. Then CPU scheduling also needed here, and the another term is swapping. That is, if process don't fit in memory, swapping moves them or moves the processes in and out to run from main memory. Achieving this goal is called virtual memory. Now we will discuss computer system architecture, or mainly types of computer systems based on the number of the general purpose processors. First is single processor system. From the name, we can understand that if there is only one general purpose CPU, then the system is a single processor system. That means one main CPU capable of executing a general purpose instruction set, including instruction from the user process. Other special purpose processors are also present which perform device-specific tasks. Apart from the main CPU or processor, there are also some other processors present which will perform device-specific tasks actually. Devices like disk, keyboard all have some microprocessor for doing specific tasks for related devices. So they are a specific type of processors. Since we have only one general purpose processor here in this kind of system, we call it single processor system. Next, the multiprocessor system. From the name itself, we can understand that in this system, there will be more than one number of processor or two or more processor. Multiprocessor system with more than one CPU in close communication, or we can say it is a tightly coupled system. Processor, shared memory, and a clock. Communication usually takes place through the shared memory. So in this multi-processor system, we have two or more processors which are closely communicating with each other because they need to work together to perform certain tasks. And what are those tasks? There may be single task, different tasks, depending on what kind of system we have. So in order to work together, they need close communication and synchronization with each other. That is why we say that they are in close communication and they also share the computer resources that they have. Now let us see what are the advantages of having this multiprocessor in a system over single processor system. So coming to the advantages, the first one is increased throughput. So the throughput is something that is used to measure the performance of a system. So in multiprocessor system, we can say that throughput is improved or increased. Here the throughput is like the measure of the performance of the system. So in multiprocessor system, we can say that we can increase performance or increase throughput. And why is this? The answer is simple, because it has more than one CPU which performs parallel work and make it efficient and more powerful. That is why what we mean by increasing throughput is. Coming to the next point is economy of scale. Multiprocessor systems can cost less than equivalent multiple single processor systems because they can share peripherals, mass storage, and power supplies. If several programs operate on the same set of data, it is cheaper to store those data on one disk and to have all the processors share them than to have many computers with local disk and many copies of the data. Now come to the third point, that is increased reliability. This is more reliable as compared to the single processor system. Why is this? Because in this multiprocessor system, even if a single processor fails, we still have other processor which will backs up and which will still keeps us running or keeps the system running. So if we have 10 processor and one fails, each of the remaining 9 processor then can pick up a share of the work of the failed processor. Thus the entire system runs only 10% slower rather than failing together. Basically, there are two types of multiprocessor system. The first one is symmetric multiprocessing system and the second one is asymmetric multiprocessing system. In symmetric multiprocessing system, each processor runs an identical copy of the operating system. Most modern operating systems support symmetric multiprocessing system. This is the most common system used. Used in which each processor performs all tasks within the operating system. Symmetric multiprocessing system means that all processors are pairs. Here in symmetric multiprocessing system, CPU1, CPU2 and CPU3 denote the different processor we have in a system. And P1, P2, P3 denote the processes that have to be executed. Here all the CPUs are similar to each other and they all are participate performing these tasks P1, P2, P3 or the processes. So all the CPUs are involving in all the tasks that is known as symmetric multiprocessing. Now in asymmetric multiprocessing architecture, a master-slave relationship is present. Master processor controls the system and the other processor looks the master for instructions. Master processor guiding or monitoring the slave processors, and slave are taking care of particular task or the process. Here slave CPU1 taking care of process number 1 and the slave CPU2 taking care of process number 2 and the slave CPU3 taking care of process number P3. And we can see that slave CPU1 can only take care of process P1 and the process P1 is not taken care of by slave CPU2 or the slave CPU3. Also, if some slave CPU will fail, then the master processor will be taking care of how the load will be distributed. Now, another important evolution of operating system is distributed system and then real-time system. So first we'll discuss about the distributed system. This is a very important approach in the modern computing. The modern web services that we use on day-to-day basis are very critical. Services like Facebook or Google, these are very much large-scale services. These services get a lot of requests all over the world. The problem is if you want to serve that all the requests at the same time with a machine, it would be impossible. We cannot make or build that kind of big one machine that can serve all the requests that come all over the world. The idea of distributed systems that we distribute the load within many interconnected separate computers which are communicate or talk to each other from side now. So distribute the computation among several physical processors. Or we can also call it loosely coupled system because each processor has its own local memory. Processors communicate with one another through various communications lines such as high-speed buses or telephone lines. Now come to the next generation, that is the real-time system. A real-time system is defined as a data processing system in which the time interval required to process and response to input is so small that it controls the environment. So in real-time system, after giving input, get the output very quickly. That is, the task is completed within a specific time delay. Often used as a control device in a dedicated application such as controlling scientific experiment, medical imaging system, industrial control system, aircrafts, or the real-time traffic signaling system, and some display system. We can use this kind of real-time systems. Thank you.